there. Hi, hi, bye, bye.
Okay, let's the participant in the room.
Okay. Hope you all enjoyed your coffee break, and it was really good to see that it was more of a networking session than a coffee break. Thank you so much. So now we move on to the big question workshop 1 for day 1, and that's on the theme how to manage microbiology to enable sustainable aquaculture. And we have 4 moderators on stage, and I would like to introduce each one of them. And first we have Professor Christopher Coates, University of Galway, Ireland. Next we have Professor David Bass, CEFAS, UK. We have Dr. Verner-Jeffreys, WorldFish, Malaysia. And then we have Dr. Olivier Decamp, INVE Aquaculture, Thailand. Over to you. Thank you.
Hello. Well, welcome. Thank you to the organizers and the sponsors for enabling this event and for the very generous introduction. I've prepared some very brief slides to stimulate some discussion and to give you a bit of a preamble to how this session evolved. Okay, it's gone a bit right. Okay. So how to manage microbiology to enable sustainable aquaculture for a moment. So these 4 questions were generated in discussion with the scientific advisor, Professor Andy Shin. So what practices are currently being employed in small-scale production? Are these practices appropriate? And what successes and failures have been observed? What is needed to improve microbiology management, and what are the hurdles to implementing or adopting these practices? Now, these are quite loaded questions, quite broad, and we had a general pre-workshop discussion via email where about a half a dozen people provided their opinions. Now, just to provide some context for people that may have been missold this workshop, when the voting was going on, we had a very provocative title of Apocalyptic Microbiology because of climate change and the drivers of change. And this came about from a discussion of biosecurity in terms of bacterial transfer via aerosols and what happens after a tropical storm. Is there an inordinate amount of potential bacterial pathogens that have been aerosolized, and how does that impact pond and water quality? And this then evolved into microbes, the good or the benign, the bad and the ugly. So using probiotics and bioflux to add good bacteria, this is usually seen as something positive and is recommended for practitioners. Using disinfection to kill bad bacteria and others, so there's a lot of collateral damage in terms of commensals. So the microbial ecosystem is completely disturbed using disinfectant. And then finally, using diagnostics and therapeutics for the ugly, including antimicrobial resistance. So biosecurity and management is key here. So that moves us on to our questions. So what practices are currently being employed in small-scale production? And this could be from the farm level. How are microbes managed or not managed in the broadest sense in small-scale aquaculture? Now, we got some replies via email in terms of India and Bangladesh, but it would be good to hear of your experience. How is this managed? And then more broadly, touch on themes from today's sessions, including the pathobiome, the systems-based approach, and interacting with antimicrobial resistance or trying to manage it on farms. Okay.
we recording this? Are we recording this? Is this session being recorded? Yeah, it is. And online people can hear.
Yes.
Yeah, it is being recorded.
Is being recorded. Okay. So these are some, to kick things off, these are some of the responses we see by email. So India, small-scale traditional methods such as poke fields integrate fish farming with rice cultivation, where fish waste fertilizes rice crops. The rice fish culture is practiced by the Apatani tribe, and this relies on natural periphyton growing on rice stems. So we heard about that from Karen this morning in a really informative talk, providing a significant food source for fish. So sewage-fed aquaculture systems in Kolkata utilize the treated sewage water to create nutrient-rich environments for fish farming, converting waste into valuable resources while treating sewage. And then in a second response, many small-scale farming situations, it is often difficult to follow biosecurity measures, but many farmers adhere to more traditional knowledge than scientific farming protocols. We invite general discussion on that. Oh, yeah.
Hello. I have a small submission. It's not input. Indo-German Development Cooperation Project in India is working mainly with the farmer institution as a sustainable model. They have small-scale farmer members of ranging from 400 to 1,000 sometimes. In that case, such a huge number, accommodate them in one place is always difficult. Virtually approach them, what we understood that 70% has access to the Android mobile phone. But because of the language issue, sometimes it is difficult to get 100% output from the virtual conversation. So in that case, how do you suggest to manage your microbiology and biosecurity to such a large population of smallholder farmers? That's, I think, there should be a discussion on this, because we have farmer representative and farmer institution representative from India. Thank you.
Very good comment. Does anybody else want to follow up on that? I think in summary, you say you've got big systems, complicated, lots of different farmers. How do you practically manage biosecurity within these complex systems? And obviously there's a challenge there. Has anybody sort of thought there's some practical ways through that of managing these complex multi-actor systems from a biosecurity point of view?
Just before answering that, I think it might be worth just thinking about what we mean by smallholders, because it could mean very different things to different people. And I think, to have a meaningful operational definition, you've got to have a purpose for asking the question, as with any typology. So I've just jotted down a few attributes. It may be that, the conversations that we've had this morning, we're considering systems that are low risk. The more extensive, the lower risk. Perhaps we need less diagnostic capacity and biosecurity when we've got very extensive systems. Less capital intensive, a different kind of risk, an economic risk. And often they tend to be subsistence, more subsistence orientated, because market barriers are phenomenal challenges as well. And therefore, the more intensive, the more coupled you've got to be towards markets. So I think perhaps that's worth thinking about, framing that in terms of biosecurity requirements, because I think there's a big covariation with the level of intensity. And for the smallest holders, the barriers to moving up intensification can be formidable. But also, arguably, inter alia, if you do move up the scale, then arguably the environmental impacts, the negative externalities expressed per unit of production could probably be higher for smallholders as well. So we've got this whole issue of industry dynamics, and once these pressures and requirements for quality assurance kick in, then we're driving industry consolidation automatically. Concentration and consolidation, two slightly different things. So, you know, where is the, considering that more holistic picture, where is the scope for longer term participation? And we also live in a world where we're seeing a transition from village to city as well, both in terms of consumption and livelihoods. So just a wider framing, but I think it's really important that we think of what, rather than just talking about smallholders, what we're talking about here. And I think it's very much about development opportunities for a group that are in a more vulnerable sort of position. So low input, low output, ties in with the natural productivity discussion that we had this morning. Yeah, I'll end there.
And I think that's a good point, Francis. And to me, it's about the messages and the different audiences for them. So, I mean, we're talking about microbiology management here. Are we going to use the word microbiology in any of these conversations? You know, maybe yes, maybe no. I mean, I sort of think back to the COVID pandemic, where, you know, who knows about the biology of coronaviruses? No one, but the whole world was listening to messages about biosecurity and epidemiology. And, you know, I've never heard so many people use the word virus before, even if that's all they knew. So we were able to get a lot of science that had a very complex basis adopted and operationally understood by enough people to, okay, variably respond to that threat. So, I mean, if we're talking about, you know, let's just say, well, any of your categories of small-scale farmers, there's a range of things that's going to matter, isn't there? One is, you know, not bringing pathogens in with something, whether that's stock or people or water. Another is, you know, I like this sort of periphyton growing on plants to supplement or actually to better mimic a real ecologically normal food web. That's another microbial thing we need to think about. AMR is another microbial thing that sort of bears no relationship in the way that people could understand it to pathogens in the water. You know, they're different organisms. The nuances in that are just beyond anyone on the ground, I think, to really care about. And does it matter if they do or not? But I remember as part of the program that we did post the initial UK, the Newton Fund BBRCC project in Bangladesh and elsewhere. I can't remember where now, but it was using videos to explain to farmers about AMR risks. And those videos were sort of quite cartoon-like in a way, and yes, they mentioned some sort of technical words. I mean, obviously they used AMR, but the messaging of those videos was very untechnical, but also incredibly powerful, and they had a huge impact. But it was based on really hard science, but sending a message that people could understand and work to. So maybe the challenge we've got here is thinking about, well, what are those elements of aquaculture at whatever level or type it might be, that need to be communicated, and how do we communicate it in a way that people go, yeah, okay, I get that there's this virus that I need to take care of, and I really understand what we need to do in order to do that, so that's what I'm going to do, without, you know, getting into any of the details about microbiology or eDNA or pathobiomes or whatever else, because there's only going to be a tiny minority of people who care or want to understand in that kind of thing. So I think that puts us a bit of a, it's quite a big challenge for us as a group, because we need to think about what those important categories of microbiological challenge, if you like, are, and then say, right, how do we convert these into things that are actually going to be useful and people are going to get and see the importance of and be able to implement. That messaging and translation is up to us as aquaculture professionals, I think, and the communication and implementation of it is down to some of us and maybe some other people who are more expert and skilled in that kind of communication. And I know there's a massive variety of people in this room, so I'm overgeneralizing. But do you see what I mean? I mean, I think a lot of it is about doing the translation and thinking up front, and maybe that's the conversation we have now. How it's actually communicated to the farmers and the industry is a bit of a different topic in a way. So I'll stop talking now.
So I I just want to make a comment about communicating to farmers and some of our experience. We use WhatsApp, but we don't have that many farmers. Like you mentioned, 400 to 1,000, that would be too big of a group, I think. Bing, 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 every day. Yeah, anyways, so we actually are now submitting a grant to do an app where we want to go through the associations, and the app would then have, you could be a member or non-member, and you can access different information through that that's relevant to the fish farmers. We could put out warnings through the app. We could do a number of things. The government could put different information through the app, and you could manage it like a website, but so that it's on phones, because a lot of our farmers don't have computers. They just have the phones. If you were to do that, there's also, because we have the same problem with the language issue, we're looking at the AI that does language translation to see how effective it is. We translate all of our workshop information, but we have to do it ourselves. So now with this new AI technology, I think we're going to have access to be able to at least do documents that might be important to them that that's not in their language for translation. So that might be an option. There are the larger industries, like the salmon industries, usually the associations have websites and probably apps as well, but that they can communicate different information to their membership. And even for disease, like they monitor sea lice and they post it to all of the members to see where sea lice is hot. So that sort of thing is much more sophisticated than probably what you want to start with. And the third option is these workshops that you can, not everyone's going to show up, so don't worry, you won't get 1,000 people, but that's a nice way to get the farmers face-to-face in the same room, and then they start to talk to each other, because a lot of times they don't have any opportunities to go and meet. And so this, if you provide a lunch, they'll all come. And when they're eating, they can chit-chat and learn more about their practices. So I just wanted to share that with you in case if that's helpful.
Thank you. I'd like to add some points regarding the first questions about what are the current practices made by the farmers. So my observation is that it's a very interesting area. In Bangladesh, the microbial management farmers naturally do, but they do not understand scientifically. Because even I don't understand microbes well. What they do, for example, in the pangasius farming, it is different from Vietnamese pangasius farming. It's the pond-based in the rice field converted fish pond. In this pond, they do not, they do not remove the water. They do not replace the water. They use the same water. And due to the same water usage and giving the feed regularly in the ponds, it creates lots of plankton production, phytoplankton, zooplankton. Definitely within this there are many bacteria and other microbes growing. And we know, David, when we are working for the microbiome analysis. And that's why pond become very green, and farmer naturally what they do, around 70% fish are fungus, and remaining 30 to 25% are the carbs. And carbs, eat the plankton and other all the microbiomes from the ponds, and that's how they manage. And they do another thing, but nobody has done research on this. What they do, they put the boiled rice. Farmers use the boiled rice. Rice is very cheaper. In some cases there are some rice. Its grain is very thick. This kind of grains are not eaten by the general people, so these are very cheap. They boil the rice, they put into the pond. And I think there is some amount, significant amount of rice eaten by pangasius and other fishes, but certain proportion remains in the ponds, decomposed. I think that accelerate the growth of bacteria and other flock. And this is consumed by the fish again. I think this kind of very complex systems, microbial systems works in the pond. This is one scenario in the fin fish pond. If we look at in the prawn farms in the south, and we see the farmer use boiled rice, boiled lentil. It has some proteins. I think there's some proportion is carbohydrates. And they use also molasses. It's a mixing together and they put into the, prawn pond. And that is also accelerate the beneficial microbial growth. That we don't know because we don't have the research work. And this is one kind of positive management farmer does themselves for the very long time. And in terms of the negativity, that means the disease, occurrence, how do they manage? There is no any diagnostic system practically in the field, and it depends on the drugs and chemical companies, and there is no any authority of the government officials to treat because Department of Fisheries doesn't have this, officially doesn't have this kind of capacity to diagnose or to suggest or prescribe the farmers to use the drugs and chemicals. That's why the companies, they are, suggesting different kinds of drugs and chemical uses, even antibiotic, and that's how the pathogenic bacteria is going to be managed. And that is the whole scenario in Bangladeshi fish farms. So there are a lot of things to do, particularly through the research to understand the dynamics of the microbes in different farming system in Bangladesh. So thank you. And of course, one more point, these are the small scale farmers. And if we want to define them, like the farm, they invest from their own money, it's small ponds, they manage themselves with their household, labor, that means their own, labor they invest, and their own money, and that's how we can say it's a small scale aquaculture in Bangladesh. Thank you.
Thank you. I wanted just to add on one of your points on the challenge, how to communicate with these farmers, because many of the small-scale farmers, their only point of contact will be a salesman from a chemical. So that means how can we convey a correct message in a way they accept it. So I think social media, or in Vietnam, we can do in coffee. I mean, in Vietnam, the best spot is a coffee. There are coffee shops everywhere, and they all meet up, and then you give one person talking to 5 or 6, and slowly you can spread the message. But I think one of the issues for us, we were trying to always identify one successful farmer who would have implemented successfully the recommendations. And that means other people would believe more, if you want, see the value of what we recommend, because they would be an example in that area. So when you have 4,000 farmers, okay, you may need a few hundred success cases to reach them out, but this is probably one of the ways then they can follow up on the WhatsApp message, knowing that someone else has used it successfully, and then they can follow up more on your message more and more because they have a sense of belief that what you say is validated by someone they know nearby.
Yeah, I mean, you mentioned so many valid points there. There's a couple of things from my limited experience in that farmers, they know how best to grow their crop. Okay, they don't need help with that. It's when things go wrong. And when we generate the scientific data, that is to reduce the uncertainty or risk that it will occur again. But it's not just a case of, us generating that information and then perhaps publishing it in a manner that isn't accessible. It's also state bodies and governments need to translate that into guidelines and legislation. And so there is a part, it's a multi-stakeholder operation, so it isn't just a case of scientists trying to reach out. There is a role for the state in doing that as well, which often gets lost in the mix, and I think is quite lazy when state bodies just pull back in that aspect. The other point you made about disease diagnosis, it is incredibly difficult when I'm thinking of my own experience for invertebrates, to even qualitatively state what is a healthy prawn or a stressed prawn. And I've spent 15 years trying to figure it out, maybe one day. And so this idea that you have no capacity on a small scale in terms of farming to intervene and to try and save a crop, I don't know what the solution is. Perhaps fallow periods would be the best if you're not going to use any intervention like probiotics or vaccinations or antibiotics to try and treat. At that stage, particularly for prawns, it's usually too late. As soon as they're showing clinical signs of disease, that's it. Like, it's game over. Any therapeutic intervention is known to fail at that point. That isn't, it's probably advice in terms of don't waste your money if you're doing that for prawns, but it's easy for me to say that, but for somebody to actually do it and get rid of their crop, it's something entirely different.
I mean, I think you just picking up on a point you made about learning from what works. I don't think we do enough of that, and I point the finger at myself as much as anyone there. I mean, there's a lot that really does work, and I know when we have conversations about it, I hear these things, but is there any robust data collection around what works, what numbers are involved? Because going back to the conversations we were having earlier about, it's not just the feed, it's so many things, water quality, what's being stocked in the ponds, density, all of this stuff. If we could somehow collect those data across a wide range of successful and less successful outcomes, with this slightly stepped back systems approach that we're more explicitly taking now, there might be more opportunities to look at those data, to AI process those data in a way to actually look at what combinations of things are consistently leading to success. And that's deliberately naive saying that, but I bet it's not actually that naive if you measure the right things and you analyze things in the right way. And maybe the problems are the outliers that are easier to identify in that big data context than they have been in the past. So we can get sucked down too many narrow routes, I think, in investigating problems or this technology or that opportunity. Maybe now taking a fresh, big picture look would be really valuable. And you might say, what's this got to do with microbiology management? But everything we do in aquaculture and in ponds is about microbiology management. That is fundamental to all of it.
Yeah, thanks a lot. Yeah, very true. What you said is absolutely right. I think everything what is about pond management is about microbiology pond management. And when talking about what practices are currently being employed by small-scale production, I definitely would like to add the point of probiotics. And because they are important, and they are a kind of also what was mentioned already, by adding carbohydrates and by producing an environment where bacteria can grow and being utilized as feed is also a practice to manage these things, because then there will be a harder breakdown of organic materials, and then it's gone, and then it's not creating problems in terms of other things. So probiotics is certainly one thing. And
pre is more important than pro?
Do
you think prebiotics might be more important than probiotics?
What is exactly the difference? Well,
the way I see it, probiotics is adding bacteria into a system somewhere or another. Prebiotics is creating an environment in which beneficial or just a diversity of bacteria can flourish and a natural balance is maintained. So by chucking rice and molasses and whatever you could be creating a very good prebiotic system.
Absolutely.
I mean, I've got my own questions, and they are genuine questions about how effective putting bacteria into an aquaculture pond is, and for that effect to persist. But I mean, I genuinely want to hear what people's experiences with that are, because it seems to be more risky than doing the prebiotic approach. Anyway, sorry, I interrupted you.
No, absolutely fine. No, the prebiotic, I think, is a very valid point. Probiotics, I feel, is important as well. From my experience working and also in research level only, in recirculating system, addition of probiotics was super helpful. Fish were sick, treated with antibiotics, disease came again, treated again with antibiotics, disease came again, nearly all died. You decide, well, this is not getting me anywhere. You add probiotics and dialysis slowly stops, and you have a stock which is healthy again. So things can change in microbiology. And what I still, as another comment, from all the presentations, I have understood that the monitoring is important, that we know which is the disease, but I'm still missing the treatment part. Apart from bacteria, okay, we treat with antibiotics, and viral diseases, maybe we can prevent by vaccines. But then,
carry on, then I'll follow.
but then, where is the treatment? As you said, when the shrimp gets sick, that's nearly it. And I agree. I have grown chicken at home. I've grown geese at home, and ducks and fish and everything. And whenever you are in animal husbandry, it's tough to get a sick animal really healthy again. And it's always having a retarded growth. So when it comes to production, it's usually not worth the effort, to be honest, financially. And this is why I feel the only option we really have is to be preventive by any means. If there is a disease coming up, the problem is already there.
Yeah, so just as a follow-on, it's good to have a clinician there in the corner, but I think if you look at, we talk about challenge curves. So if you infect a population of fish in a tank, we talk about a curve. It's not a wall. They don't all die. After typically 40 to 60, even if serious disease, 30-40% will die. If you work out when people medicate, when they start seeing fish as sick, it's normally quite far up the curve. One of the key symptoms for most diseases is inappetence. You're medicating with feed. So that means most of the fish, when you start medicating, they're not even going to think. So I think we need a little bit more kind of evidence to farmers that often, applying antibiotics in feed is almost too late, because they're probably that 30-40% going to survive anyway. So there's a comment about the follow-on. I'd quite like to sort of move this on to the key interventions. And one of my hobby horses here is we talked a little bit about green water and flock systems, but vaccination. I mean, why isn't it more widely deployed? I mean, there's lots of reasons. I just need to hear I've got some of my own ideas, but I need to hear from the audience about why everyone recognizes that, where obviously for shrimp or whatever, different story, but for finfish, we know they work. We know actually not often that expensive. So why aren't they being more widely deployed in Asian and African aquaculture at the moment? I've got my ideas about that, but I'd be interested to hear what the audience thinks about that, because I think everyone recognizes that they're a potentially key intervention and tool to stop using antibiotics in particular. Just over to comments, really.
Just quickly to this, because I'm not very familiar with how to vaccinate fish. Maybe you can give a quick brief about how this is operating, because if you think about vaccination in humans, so it's an injection. If you imagine, I got to inject every fish, this is not going to happen.
Well, it does. So no, I thought it does happen. It does happen in the Norwegian industry. Every fish gets vaccinated, goes to sea, gets 4, 5, 6 things. People have shown even in kind of semi-intensive systems. If you're a hatchery and you're vaccinating an injection, it is possible. There's also a lot of work at the moment to develop oral or immersion vaccines. So I'm interested to hear researchers. I mean, there's various reasons why I think they're not being used, and I think sometimes, frankly, it's regulatory or supply. But I'm interested to hear comments. Anyone? Yeah. Yeah.
Thanks, David. A question which needs a lot of deep diving. I don't think we can give you a very short answer to that question.
I'm not expecting one.
Right?
No.
Yeah.
Just to
I mean, before I say anything, few minutes on vaccination, but it's another aspect of this AMR that we need to look at. We talk about AMR as a problem of antimicrobial use. We also, in a way, in this discussion also, we target smallholders. Right? How the smallholders operate in different parts of the world is different. We also discuss a lot about Asia. But remember, Africa and Latin America are 2 other regions where a lot of aquaculture comes from, and there are thousands and thousands of smallholders. Right? And you go to a pond in Nigeria, 2 species, tilapia and catfish. Catfish is 95%, maybe 5% of tilapia. You go and ask someone what's in your pond, he doesn't know. I don't mean that 100% farmers are totally sort of illiterate, but unfortunately there's no management in the pond. I think we talk about it. Even you don't know what the biomass in your pond, how many fish in your pond you don't know. He's expecting with his harvest to build a new room to his house. But once he go into the harvest only, you realize, I got only 100 kilos. It just doesn't know, right? The problem is you cannot improve individually one by one. There are too many, right? You cannot physically go to a pond and tell them what to do. It will not happen. Why they use antimicrobials? Because it's available. The accessibility, availability. Who's responsible? The state is responsible. So there are different aspects. If you have a good insurance system, you probably wouldn't bother because you get a coverage. There is no coverage because your system is poor and there are no standards, right? And antimicrobials available, you just chuck it because you need to protect your stock. Even you don't know how much it is in your pond, right? I think it's quite a complex situation. We really need to, like Melba's, PMPAB, sort of it's difficult. I've been working in Nigeria for the past 6 years, right? And it's a real mind-boggling thing, what you could do. But I'll stop at that. And regarding the vaccination, I think the main reason for us is situation is changed. Like in Ghana, I'm pretty sure you have experience in Ghana, David. INVE kills very young fish. Yeah. Even if you have a vaccine, you cannot inject because they die before 10 grams of size.
Yeah,
right?
And the issue there is that all the farms are online, the hatcheries.
Absolutely.
So you've got a constant pathogen exposure.
Absolutely.
So how can you prime fish if as soon as they hatch, they're exposed to the pathogens? So you need yeah. So I think that particular situation where you've got
That's where you need to find the solution of effective vaccination at early stage, right? So you need new equipment. You need new equipment. You can injection vaccination at 10 grams level, right? You need to develop good immersion vaccination programs, right? By the time it goes out of the nursery, you're basically covered for at least 1 or 2 pathogens. So that's possible. The other one is Big Pharma doesn't want to come into Africa. They have no confidence in working in Africa. They think it is too much of a financial risk to work in Africa. I talked to 3 or 4 major Big Pharma, and only one company showed interest in working in smallholders in Africa. The other said, forget it. I think there is you need to make the barrier, really break the barrier, right? The smallholders are an opportunity. It's a business. It's an opportunity, not a problem. But everybody thinks like a smallholders is a problem. I'll stop at that.
Thank you.
Sorry to interrupt. One quick addition I would like to make to the first slide, still what is practiced to overcome or to deal with microbiology and diseases. And this has been touched upon further. There was the multiple stocking, and I've worked in Bangladesh on shrimp farming. And in Bangladesh, there's a very extensive system where there is a constant stocking going on every week, every other week, every gone, there's stocking happening and harvesting happening. During the rainy season, most of the shrimp, or very often shrimp, die, because especially the bigger shrimp die because they are less resistant to salinity changes. And ponds are shallow, heavy rains come, salinity changes, but they continue to stock. So I would think actually, because the PL is very resistant against salinity changes, this is also a procedure to deal with it. It's a multiple stocking, so you don't have all your eggs in one basket. You don't stock and then let them grow and then harvest at one point of time. And if something happens in between, all your stock is gone. The constant stocking, the constant harvesting, like with the tilapia, the intermittent harvesting system we work with in Malawi, is a measure how to deal with the risks, because you have a regular income, and if a failure happens, it doesn't hit all your stock, but only a part of it. Just to add to that, procedures, what people do.
I'll pass to Olivier, but a comment is obviously in the big intensive systems in Norway or whatever, they have all in on a regional scale to kind of minimize the biosecurity risk. So there's this tension, isn't there, about how do you best principle biosecurity with the reality on the ground and the economic reality of people and farmers often needing a constant flow of income. They can't wait a year to get their next paycheck. We get it. Yeah.
So a couple of points. What you say about the PL quality, I think it's really important. And the challenge we are seeing, if you look at the PL, I mean, I'm not talking about some market, but the biggest countries, let's say, where you have a large supply number of hatcheries, you may have 2 or 3 grades of PL. So you have the premium to go to the top producers, then you have the one intermediate, and you may have the lower price. The lower price typically are coming from unidentified broodstock or specs. These are the ones that the small players, the small farmers can buy. So in addition to having limited means on biosecurity and management, they also typically source and stock the weaker PLs, which will impact further down their production. So this is where, with ND, we're looking at other ways how different companies could support to make sure the small farmers can have access to better quality PLs at an acceptable price for them. So not the issue. Regarding the vaccine, one of the problems we saw, I remember we talking with a few people, in the past, the first vaccination process, I think, in Thailand, for the tilapia with strep, came with the wrong serotype. It did not work. And this is okay, understandable, but the problem is after that, all the farmers think vaccines don't work. And so we need to start to clean up that initial error. And I think this is one of the challenges. Now, there are a lot of actions going on in Thailand, and I think it's going to move in the right direction now, but it was one of the issues.
Thank you very much. Christopher, I love the title you put on the first slide. It's the good, the benign, but I want to move that into its own separate category, the bad and the ugly. And I want to go back to the best practice comment that's been made several times. And I think we really probably have to focus, David, in terms of your comment about, how we deal with treatments. And we do have to think about best practice with regards to how we properly apply probiotics. We need to think carefully about disinfection. It was highlighted by Sophie. But I also want to touch on, for example, we also have a responsibility when we're taking water from and discharging into common water sources. So, for example, we need to make sure that the water we discharge is appropriately treated. Otherwise, we're just driving infections.
Can I make a comment about managing the bacteria in a pond? For small farmers, sometimes we have problems managing the fish. Microbiology for them is a lot harder than fish to manage. So if I'm going to go and make a recommendation, I need to know how to assess the pond to know if it's okay or not. And I don't think we have a profile that we want, like that we know, okay, we need to get this profile going and how to do it. So it's very difficult to make recommendations. And we've tried probiotics where follow the label on the thing and it doesn't work because it's like one off, dump it in, it's not going to work. So we're slowly recognizing that to change the microbial community, it takes a lot of effort, probably more than farming a fish, I'd say, for me anyways, because I find the fish farming is a lot easier than managing bacteria. So we qPCR to see, okay, I'm putting in bacillus. Am I getting bacillus 3 days later, 7 days later? Anyways, so it's hard. I think that's why we don't have yet a good management strategy for the microbial communities. And then one other thing I want to point out, believe it or not, I'm actually an introvert, but when it comes to aquaculture, I get excited. We've done some research to look at disinfection of water because we wanted to clean it up a little bit. And I can tell you, and actually as a vet, sometimes we say, use a surface disinfectant instead of antibiotics. So you've just got ulcers, maybe you're in a RAS system, clean it up with some chloramine tea or something like that. Ozone, we're looking at ozone. And what we're finding is that the survivors of the ozone treatment in the microbial community actually are the tougher organisms. And it causes upregulation of a lot of their efflux pump genes, which are the genes that they require to spit things out, whether it's like ozone or chlorine or an antibiotic. So you select for those, and sometimes those also have acquired genes in them because they're the tougher bacteria. So it actually, I don't know if it's that good of a thing to do low-dose disinfection, because if you've got fish in there, you can't blast it and disinfect everything because they'll all die. The fish will die as well as the bacteria. So you've got to be careful when you make recommendations to disinfect water when there's at least animals in there, because we're finding that, we're maybe selecting a little bit for things that we don't want to select for, and classic would be Pseudomonas, right? So just a note on that.
I mean, I think almost anything we do to ponds selects for things, particularly bacteria, that we don't necessarily want because we're creating a more artificial, a more stressed environment. Which is why I still sort of go back to wanting to understand more about these, either the prebiotic inputs that we can put in to at least give the bacterial assemblage a chance to be something like an ecologically stable system, or to have a balance of things in that the fish can cope with. Whether that's by putting in rice grains, whether it's by having the restaurant in there. There's been a lot of talk about growing filter feeders and plants in ponds to maintain water quality, and also has a massive impact on the bacterial and the planktonic communities as well. But I don't get the sense that there's much, or certainly where I've been working, there's much uptake of that. And again, is that just a problem with the uptake, or is it because we're still dithering about how to do it, whether it's worth doing, and so on? So, I mean, I think there's quite a bit of thinking, whether it's via these networks, just communicating, whether it's R&D, into what is, if not best practice, at least reliable practice that is implementable and that we could actually start reinforcing the communications about, so that things actually do start happening. I think there's some fairly low-hanging fruit there. That doesn't mean everyone's going to take it up and it's suddenly going to be a golden bullet, but rather than chucking antibiotics into a pond, maybe there's some local business opportunities in terms of these more sort of ecologically sustainable things. I mean, the vendors have to get the antibiotics from somewhere and flog them on, and they're often quite cheap. Could that not switch to a probiotic mix, or some plants that you put in your pond, or a bit of gate that you put the restaurant in? I mean, this is all economic questions and socio-economic questions way out my area of expertise. But you think there could be some kind of switch there. So sort of keen to hear anybody's views on that. And just the other thing, back to the probiotics. And it links to the antibiotics as well. I mean, if you surveyed 500 farmers about the results of them putting antibiotics very randomly, as I guess often happens, into the ponds, compared to another 500 that put probiotics randomly into the ponds. And I think we know for both of those things that what's in the tin is rarely what it says on the outside of the tin. I mean, probiotics in particular, as I know you know, Francis, from work you've done and work we've done, bears no resemblance often to it at all, just absolute rubbish. So, both sets of 500 farmers are compromised here because they've not been putting in what they thought they were putting in. But, I mean, would there be an actual evidence-based consensus in favour of the probiotic? Or do people still have a strong sense or evidence that the antibiotic is doing what they want it to do? Francis?
Thank you. Yeah, so the probiotic, the fraudulent, the snake oil problem, and you mentioned it this morning. It's a common issue, regarding of whichever therapeutic you're putting in. Ironically, you're finding situations where the antimicrobial content is not what it says on the wrapper. A big part of what we were doing, and many government regulatory systems are checking to see that there's no antibiotics, because there's inducements to contaminate everything with antibiotics. So we were finding evidence of antibiotics in otherwise poorly performing probiotics as well. It's worth noting that, you mentioned the pre and the probiotic, where do you put in? Do you enable the beneficial bacteria, thereby working on prebiotics, etc. But also it's worth noting that, you know, there's two broad applications to treat the gut microbiome and the pond microbiome. And I think it's really important to validate, you know, these discussions by just simple empirical assessments of what farmers are doing already and how their behavior is modified by their capacities and also their ability fundamentally back to managing risk, our definitions of small scale. So some of the work that you mentioned, we found that, you know, the bioremediation is just too expensive when you go to a pond scale. So the bioremediation applications are in the hatchery, okay? And also we found interactions between scale and the propensity for farmers to treat therapeutically or prophylactically. So, you know, ironically, in hatcheries, smaller scale hatcheries, only wait till they've got problems and they're treating, you know, as a probiotics as a non-vaccine based prophylaxis, they're using them as therapeutants. So I think it's really important to do the empirical and validate what we're doing. And, you know, many of the questions are there just through these simple validation steps. Just one other...
How much evidence do we have on all of these things? Because there's loads of questions we're talking about now.
Not enough.
Are there data out there that we can actually use?
Not enough. And I think this is where we do the Q squared stuff, the qual quant, and we've got to mix it up and do more of that into multidisciplinary. You talked about systems analysis. It's great, systems thinking. But what you're describing in microbiology are fundamentally complex systems, whether there's nonlinearities, interactions. And what we're essentially trying to do is, you know, is look at a whole. It's a non-reductionist way of looking back to getting away the triad to thinking about more holistic problem. But it's complex, and perhaps we also need to think about researchable constraints, because at some point we've got to allocate resources.
We certainly need to pick our research battles better than we have been, definitely.
So, is it fine? Sure. Sure, I pass it on. I wanted to share just, it was good that you spoke about this, and I wanted to share anecdotal evidence. Of course, not a research-based data gathered, but Jens can also help in the, if I'm not very clear technically. We shared a video. It's 8-9 months back. The video was, how do you prepare effective microorganism-based feed at a farm, in your farm? Simple. And how do you make it effectively? That video was shared in WhatsApp, and we just did that, okay, let's just distribute EM across 200 farmers, and let's see what happens. It's 7-8 months back. And now, what I got last time from the field, strangely, the idea was that farmers would use the EM-based feed, and that would increase the digestibility of the feed, and of course the FRC would increase, and blah, 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 all that. But apparently, farmers are using that solution as a medicine. And I was like, what? What medicine? Well, yeah, they are just calling it a medicine, and they are using it not on a regular basis, but as a medicine in between. And I don't know the reason and why they're doing it, what they're doing, but we did not go, as I said, in data and all science and everything. We just distributed EM, we distributed a video, how to do it correctly, and now we are getting a feedback that they're using it as a medicine. Yet to go in details why what, but it's an anecdotal sharing of what is happening in Orissa. And our colleague, he is in Assam, a different region, and I'm passing him over.
Thank you, sir, for giving me the opportunity to put a question. Sir, I'm a farmer, so I don't know much about a lot of microbial activities and all, but I know some few things like how to measure pH, how to measure dissolved oxygen, how to measure planktons. But many farmers do not know these things. And they are very easily approachable to private, and companies are very aggressive and they are every nook and corners they are available, and they come up with lots of products, probiotics, prebiotics, soil probiotics, gut probiotics, water probiotics, sludge remover. How much reliable? How can we rely on them? And if a farmer encountered this kind of problem, they can easily be motivated by the companies. So I want to know opinion from your side. So how we encounter this problem?
Well, I mean, I think we're saying here that we don't know what the best probiotics are, and we don't know how to get them into the system, and we know that what's in the packet is not what it says in the packet. So I think, does that answer your question? That it's very difficult for us to be able to say, yes, it's reliable, because we don't know a lot of the answers.
I will support his questions. Yeah, regarding using the probiotics and biofloc to add the good bacteria or beneficial bacteria, I think 40 years or more than 50 years back, these small-scale traditional aquaculture farm like paddy fish culture, rice fish culture, which helps to form the periphyton-based culture or biofilm-based culture. These two methods is already sustainable, and even these two methods helps in supplying the beneficial microbial as a live food to the target species, as well as these systems can help to recycling the nutrient recycling in the culture systems. So now this our two objective is to recycle the waste as well as to supply the live food. So whether my concern is to whether we should go for the using the probiotics and biofloc to add the beneficial microorganisms. Thank you.
Just if I may jump back to your question, I think it's most important. So first of all, I think there's a general consensus among those speaking that we lack empirical evidence to say why exactly it's working without intervention, and we don't know. You know, how do you manage? For companies, there's two things. One, they need to make money. And so they're going to suggest that you have some sort of agent at pond inception that will keep your water clean, will establish a very healthy, robust population, the water chemistry, etc. And then nothing will happen. So you will continue to use that strategy. And then you only intervene when something goes wrong. And it's very easy to define when things go wrong, but not when things go right, in terms of if you stopped using a probiotic or if you stopped spiking the water. And then that leads to multiple interferences in your pond, and then you will continue to do that out of best practice because your crop is now healthy and so on. And they will continue to sell you those solutions. But it's perhaps worth trying to figure out from our side, why is it that this small-scale system is so successful for so long? And then when things do go wrong, try and figure out where they went wrong, rather than use some sort of expensive and/or chemical and/or environmentally hazardous solution. In terms of the probiotics and bioflocs and so on, in terms of prawns and shrimp and so on, probiotics don't work. There's not a manuscript that I have reviewed out of hundreds where they are suggesting this single particular bacterium is going to increase feed conversion, it's going to make your prawns bigger, they're going to be singing and dancing and packaging themselves and driving themselves to the supermarket. There's not a single incident. But in our own trials and data we've published, they're usually totally benign. They don't have any measurable impact on the system. Now, there are successful cases for maintaining fish populations. It's a different, it's a different biological system, for sure. But the reason why you intervene in the first place is because you want to produce more for less. So if you invest in maybe prebiotics or a prebiotic system or probiotics, you'll get more biomass that you can sell out of your farm. But the point I'm trying to make is it's a balance, and if things do go wrong, but then you'll continue that habit, for your lifetime, rather than think, is that needed the next year or the year after, or when you've replaced your biomass, when you've changed it?
And I wanted to add a little point. As you can see from here, I'm coming from the other side. I'm from the devil. So, but because I've worked since 2002 on probiotics commercially, so I'm not hiding this minor element. But I wanted to just put a couple of points regarding the issue of what is on the product, on the label, and in the product. I think we all agree on how critical it is. We ourselves did a survey of about 80 products commercially, and I think we found about half of them had between 10 and 100 times less bacteria than what is on the label. We sequenced them. In many products, there was nothing as was on the label. Some had some minor issue, which as producer we understand. So this is one of the main problems. Second one, when we look at the registration, we have a factory in Thailand, we produce in Thailand, register in Thailand. It takes us about a year and a half to register a new product with the Thai authorities. We need to send samples to all different labs to check everything. You do in Ecuador now, it takes about 1 year to register a product. So it means if you are coming from a company, not only us, there are many companies with the same process, you need to go through all this. The problem is in the market, you will have then all the others, they do not have to follow these. And this is a big issue. And the final point about the performance, the challenge that I see is that when we carry out research on the lab scale with 5 replicates, 6 replicates, and 2-3 treatments, yeah, sometimes good, sometimes bad, not the same. The only time where we see really value and how we can sell to the large companies is because they operate 500 pounds, 1,000 pounds, and they will see the cost benefit for them. But you're right that all of us are interested in documenting further because it's of value for us, but also how we can develop something better in the future.
Yeah, absolutely. And I'm pleased, I'm not saying all companies are bad by a long way. No. But I mean, there are a lot that are in a position where they just have to make the money. And sort of interestingly, there's a few bit of the intervening conversation talking about biofloc, which is essentially a natural system. And there's quite a good set of data about biofloc as opposed to probiotics, right? Similarly, the prebiotic thing, if you create a natural environment, even if it's not really that natural, but it's more natural than just throwing in a few different bacterial species, then the system has got more chance to be resilient and adaptable and successful. So the more you can mimic natural systems and natural products like biofloc in your ponds, not guaranteed, but the more likely it is to work because it's a self-regulating system. It either doesn't establish, in which case, you could refine it, try it again. But if it does establish, it's already more dynamic and more resilient than adding 1 or 2 things. But I'm interested in, how, obviously, I was having a conversation earlier about industry investing in itself, which when the industry is sort of has enough resource and real ethical interest, it will do. Do you see that on the increase amongst sort of other companies that you know about, or what's the direction of travel if there is one?
You mean for microbial management per se, or in general?
For pond
okay.
products, I guess.
What I see, if I look at farming, if you look at microbial management overall, or pond management, and you look at the investment as a farmer, we always assume that the investment is between 15 and 20 US cents per kilo produced. I'm talking more intensive. The extensive do not invest so much, but if you look at this about the level, if we assume 15 cents as a reference number, it will vary between the countries. We assume about half of them will be for water treatment, including fertilization, disinfection, whatever. And after that, you will have half-half between immunostimulants or the additive you put and some other treatment. So it gives you an idea of what the farmer accept. After that, each company who develop product has to think how the product you would come up with, a protocol, would fit in that and deliver value with this range. So all the serious companies, and there are many around, will work in that way. Now, if I'm a salesman for another company, I just need to convince a farmer to put all his money in my bucket. Yeah? But in our side, I'm more on the R&D side, so we develop with that idea. And most companies, I think, do that way, the sales company. And the large producers check us on that continuously.
I would like to share with information like how we are now the culture of the aquatic animal. Exactly, it's the first world. I think before we are like the biosecurity or this, that means we need to checking about the water management condition, whether you make it for like the suitable for the animal or the growing well condition. That means as long as you can like save your risk. Then second is I just thinking we are now the discuss of the probiotics. Okay, where the major problem from the fish or shrimp, I just thinking is the first of all is like the bacteria, second is the vibrio, third is the parasite. Then which one is the serious problem for animal in when you culture of the shrimp or fish? I think is I guess we need to think about the control what purpose for use the probiotic is the probiotic is a two issue, majority is the two issue exactly. First of all, I'm purpose for use for vibrio control exactly. Vibrio, then now we need to know the probiotics, what kind of probiotic we need to use. First, just now the Olivier mentioned of the bacillus strain. Then most of the farmer use for EM. EM is the aquatic, the effective microorganism is mostly is the lactobacillus. Then third of mostly the people use the PSB, photosynthetic bacteria. So the different of the strain of the bacteria, they have the different work effective also. So now we are the gut, just now the mention of the gut effective or water effective. We need to know which bacteria can work for this part. Just now the problem is the probiotic. We can get it, our life is every day you can take the yogurt. This one is a lactobacillus. But we need to know. That's why I just thinking is when use the bacteria, the probiotics, that means probiotic what help for when we need to culture the fish. This is mostly we need to secure of the vibriosis. So for my experience I'm culture the banana when during series of the EMS in Malaysia. So daily I monitoring for vibriosis using by the TCBS. So how just now mentioned of what level of the bacteria are like the vibrio or we need to control. I just for my experience to share with you, I go to maximum is power 4, 10 power 4 maximum. Then after I treat to the probiotics like the bacillus strain, then next day is the reduce at least power 2 or power 1. So daily control. Then luckily I fully harvest for banana during when the EMS in Malaysia time. Then second is when I culture the pond culture, mostly the pond culture, I use mostly bacillus and the lactobacillus. The lactobacillus is mostly I coating with the pellet use. So this one for her. Then everything is we make it for the good condition. Then some is need to seek the thing about the water condition, water parameter. So the pH, mostly I check for 2 points daily of the, like, the water temperature and the pH. pH need to belong to at least 7 to 8.5. Then their time is all the, like, the aquatic animal is a good condition of the pH level. But pH level is you keep for less than the 7.5, more than the 8.4 something. That means during the nighttime or daytime is a lot of the fraction of the, like, the deer or animal getting the many stress. So how you measurement of the water parameter, this condition, then after we can use for our probiotic or many kind of the probiotic available in the market. So one more thing is please don't use when you use the probiotic, please don't use the antibiotics. People don't know what is the probiotic, what is the antibiotics. Antibiotic is when you see, that means you are lost of all the bacteria, but good of the bacteria from water. So please, this one is the most need to separate use. Then, water, I'm just thinking is the important is the behavior control in the water condition. That means I think we can get it at least reduce the risk of the production. Then some more I just share with you. When we driving the car, without car insurance, we cannot drive. So the probiotic is, I'm just thinking is for aquaculture is one of the most important is insurance. Yeah, so that's it.
I mean, I completely agree with the points that you've just made. Thank you for that. I guess when you're maintaining water quality, microbial diversity is an indicator of water quality. It isn't just the hard chemistry, salinity or pH and so on. And it's been demonstrated many times, and I mean, David can attest to this, it's not the number of bacteria that you have in the water, it's the diversity that dictates the health. So their functional and biochemical diversity. And it's by competitive exclusion of having a diverse bacterial population in your water that will keep the likes of Vibrio at bay. The reason why you would use like lactobacilli is they produce an acid and the Vibrios don't like that. So but competitive exclusion using microbes has been done for decades. This is just the term we use now. But you can get bioflux that have varied lactobacilli and bacilli in that, and that will keep Vibrio at bay. So it's a way of indirectly, treating the water for keeping Vibrio. But not all Vibrios are bad. Some of them have very key biochemical functions in the water. But I would agree that Vibriosis and Vibrionids are they're the universal disease makers for aquatic animals, not just fish and shellfish and so on. So I was very interested to hear about your levels. So if you have 10 to the 4, then that's it. You start to intervene. But below that, you're okay. I thought that was quite interesting. And the other aspect in terms of insurance, we're not going to solve that problem. Because it's the aquatic environment is still perceived as inaccessible compared to the terrestrial environment, and we have an extremely poor understanding of how many animals live in the aquatic environment. So it's unsurprising some pencil pusher in an insurance broker's office is unwilling to insure fish and shellfish. I mean, it's really that simple. They just don't understand.
Thanks following on from that. I think, it's it's dangerous to say that probiotics don't work. It's just very challenging to prove how they work under what conditions, considering genotype interactions. So from trial facilities to the field is a cataclysmic step. Is an exponential step. Sorry, and to demonstrate that they work, the gold standard would be randomized controlled trials. But at a population level, you have to indemnify the placebos as well, the insurance, and it's just hugely costly. And practically nobody has done it in aquaculture. So that's the challenge. And back to the empirical, where we've got good evidence that something seems to work. And what are the alternatives? Is biofloc a simpler solution in some cases? But there are some basics as well, precautionary advice that we can give to farmers. You know, if you've got declarations on the package and you've got an arm's length of ingredients, I'd start to worry. You know, a few, you know, substantive ingredients are probably going to be a better mark of efficacy. And, you know, conditions, storage conditions, are they sporing species that can withstand some very challenging conditions locally? Reference collections, is what's in there being conserved from batch to batch? You know, these are all hallmarks of reputable, quality assured production. And passing these messages on to farmers is probably a very good thing. Avoid, you know, it's a traffic light system to try and avoid the snake oil from the more quality assured that are likely to be doing some good.
Did you find that the shorter lists of contents as well as being more efficacious are also more accurate?
Absolutely.
Yeah.
When we did all the quality assurance, the lab quality, that was a very strong correlation.
Yeah.
And also just looking, you know, functionally at what's in there. When you see, you know, obligate anaerobes with aerobes in there, you know there's a problem as well. So just a basic sort of checklist, some very simple extension advice that can come out from that.
Yeah.
And then also getting industry bodies involved as well into committing to supplying these quality products. Following this kind of code of conduct is another way to foster adoption as well.
Yeah.
Yeah, and so I think probably as a follow-on comment, isn't it, is one of the issues is you know, enabling regulations, sort of governments that have properly informed and putting regulations in place that are encourage the uptake of effective, safe products, you know, vaccines, whatever. So you actually can, you know, if you either process to make the companies in the country, or if they're not available, get them in. You know, things that, well, frankly, the whole availability of medicines in aquaculture to treat things is a general problem. It's the same in the West, actually. There's, you know, the cost of developing a product, going through the approvals, is very onerous, and so it's sort of, you know, the precautionary principle can often be taken, in my view, to the extreme when they come to licensing, and often it's knowledge. But yeah, having an enabling of effective regulations that are going to enable uptake of effective and safe products. But I'd imagine companies would probably agree with that. It varies, yeah. So they're different areas.
And there is a hugely liberal trade across. So if you map the origin of these products and understand the hotspots and such, they're coming from all over the world. They have, you know, potentially robust transport pathways. There's probably an AMR issue in terms of lack of regulation. So there's much bigger issues around the regulation. Regulation is good at this. So for example, you also have India are more concerned with making sure that there's no antimicrobial. It's not yet another route for antimicrobial. First thing is registration, then checking with reference laboratories, then sampling the genes to make sure you're actually sampling the laboratories. So there's a stepwise process. It's slightly different regulatory challenges.
Hello. May I have a couple of comments? The first, I think we are talking about microbiology management. So this term, I think everyone here understands what is microbiology. But for farmer, different countries may have different, you know, backgrounds. And I just heard that one farmer mentioned that they don't really understand what is that. So we need to use some term that is more common for not only scientists, but farmers can understand. So when we talk about, you know, microbiology is a component of aquaculture system. And when we talk about management, we cannot separate microbiology out of, you know, One Health. So we talk about One Health, we talk about aquaculture system. And if we separate only the part of microbiology, that one, you know, everyone knows that is interconnected with other factors like water qualities, feeding management, stocking densities, weathers, and other factors. So I would recommend that we talk about, host. It means our animals. We talk about environment, and we talk about the pathogen. And microbe will be the part of water, and will be the part of pathogens. And when we talk about how to manage that one, I don't think anyone here can say give absolute answers about how to make the best management. Yeah, because different hosts, different system, different country, different farmer may have different experience. So we talk about, but I would say that we would talk about how to make it balanced. Microbe we have harmful and useful. So how to make this ratio in the balanced status. So this is the first comment about microbe. The second comment I would like to, someone talk about vaccine. Yeah. And we understand that vaccine work, and COVID-19 I don't know, somehow make farmers understand how vaccine work. Yeah. And before that, they don't believe in vaccine, but now they believe in vaccine. And if we talk about AMR, and we have the alternative to antibiotics, there's many ways, but in my views, a vaccine would be the way that we can go quicker, and we can go, develop quicker. But most of vaccine now, we don't have the knowledge about, vaccination for early stage. So for human, for example, when we compare human pregnant, you get vaccine, right? A baby get vaccine. And then when you go up, you get several vaccines, so you have the program for vaccination. But for fish, only 15 grams, you start to do injection. That is not possible because maybe they already have the pathogen inside already. So we need to think of, how to do vaccination from broodstock and how to do early vaccination when the fry start to have immunocompetence. Yeah, and that is a combined program, not only wait until the fish reach to like 15, 20 grams to do vaccination. So that's my second comment. And the second comment, I think that is fall into management of harmful pathogens in aquaculture system. Yeah, but we also need to talk about how to manage a useful pathogen as well. I make that balance. Yeah, thanks.
Excuse me, we have 5 more minutes left, so we'll wrap it up with a question and a small concluding discussion, please. Thank you.
Good evening, sir. I just want to ask one thing. Is there any parameter, water parameter that in a farm level, a farmer can understand the microbiology system? Is the pond is good enough with the microbiology? Another thing is how a farmer can make probiotic and prebiotics itself in a farm level. Is there any way to make themselves so they don't have to buy from a company or they don't have to, hesitate with something? Thank you.
Oh, I wish I knew the answer. They're 2 very important questions. I mean, the first, there isn't a sort of a magic or a universal water quality indicator, because there is a tolerance range, and that the gentleman that spoke earlier on about the pH range, I mean, going from 7 to 8 is an unbelievable range because it's based on a logarithmic scale when you think about it. So they demonstrate inherent resistance. So I would say a range of tolerance rather than a specific value for temperature, pH, and salinity, and so on. The second one, how to brew your own biofloc or probiotic batch. I think you're doing it inadvertently with the general traditional practices that are used. Like we saw in Karen's really interesting presentation, if you were dropped in the middle of nowhere, how would you start to establish an aquaculture pond? And quite a lot of the compost and grasses and so on that you're inputting, they will naturally seed the water with a microbial community. And then over time, you'll get, as David would call, a balance within the system. You'd have some sort of ecological stability. But in terms of a... Yeah?
Oh, no, don't let me...
I was just saying in terms of a specific way, a technical guide to brewing your own biofloc or probiotics, I certainly don't know. And if any very clever people in the audience know, please reveal your secrets. So there you go. Yeah. Well,
well, you can actually use this EM. It's certified organically, even. This is not you're not fermenting your own stuff. Yeah.
But I mean, just to add to what Christopher was saying, I mean, it's very difficult unless you've got the equipment and the knowledge to measure the microbes in a pond. And if you could, how do you interpret it? I mean, that's a question that still isn't resolved with people who spend their whole lives doing this. But, I mean, in terms of the parameters that you can measure in the pond, and I'd be really interested to know what water quality parameters people do measure routinely. I mean, we heard temperature, pH, I imagine salinity. What about sort of dissolved oxygen, nitrate, phosphate levels? All of those will influence the bacterial community in there. And if they deviate from a range, then that will affect the bacterial community in a way that limits it and will possibly lead to problems. Also, if they fluctuate madly as well, that will have a huge impact on the microbial community because it goes outside of those tolerances that Krista was talking about and means that the bacterial community has to adapt often on a daily basis. For example, if the pond goes anaerobic, anoxic overnight, then that's going to change the bacteria, then they change again in the day. That's going to limit the diversity and compromise the ecosystem in the pond. So a certain amount of physical, chemical stability is important, as is having structure in the pond. Whether that's a physical structure you put in that allows non-benthic bacteria to grow, periphyton, that again, it just mimics a natural system. Plants are amazing in a pond, not just because of their direct their own influence on the water, but because they are then home to a totally different set of bacteria and microbes that would be there otherwise. So then that's another natural solution that you can do, anyone can do, that will have profound and beneficial impacts on the microbiota and therefore on the food web in the pond. I don't have that information, but I mean, I think what's important is that we get from this conversation some of the key interests that are coming out. And going back to the sort of information sharing I was talking about earlier, I'd be really interested in trying to adopt some of this into one of those platforms that everyone who has an interest, whether it's a scientific interest or a practical interest, can engage with. Because I do think there are some real fundamental pieces of good advice that can be made available that are perhaps hard to get to at the moment. So it's something we can take forward as a result of this meeting. But we've probably got -1 minute left and 2 people want to say something. So very quickly, Jens, and then...
Just very quickly, but my question points into a different direction, because from my understanding, most of the problems regarding diseases come from intensification, accumulation of organic matter, decrease in oxygen, increase in other organic matters, which is then degraded by bacteria, leading to uncomfortable situations, decreasing immune system, fish getting sick. Now, if we look at all the approaches, they, of course, aim to prevent this, and also vaccines are given in order to prevent the infection with one or the other pathogen. But are we not looking are we not going into a dead-end road? Because if we succeed over Vibrio, maybe another bacteria will come or another virus will come, so that this will be a continuous process, because the issue itself is not solved yet, and the animals themselves are not resistant enough. And since there is so much immune system build-up in the hatchery, and the hatchery is also an environment where most of the microbes are being tried to kept out. So I think with the management practices, especially the good management practices and biosecurity and all this, we actually produce extremely weak animals regarding disease. They are very strong regarding growth, but we've heard this already, that the selection is not in disease resistance, selection is in growth and performance and all this. So are we not creating our own problem and probably could shift towards disease resistance, selective strains, rather than putting everything in growth?
Yeah, I think the EP triangle, I think there is also, frankly, some very, very bad bugs out there, like absolutely nightmares. You get them in. I've seen examples where we've had incursions into a country, the same in terrestrial, same in human diseases. You can get something you get in your system, and it doesn't matter how healthy or happy your fish are, they're going to go down. But these are probably the exception. So, yeah, so there's a bit of both.
And also, if you get, you can put massively resistant animals into a pond, but if that pond is very unnatural, then there'll be no resilience in there. So one of those things come in, take over, opportunists. So it's you do all that pre-work and then you destroy it by putting them into a totally unnatural environment. And what we're trying to get to is to make that environment where they grow out to be more natural and more resilient. But it's a good debate, I think, and that is two sides of the same coin. But last question of the session.
Yeah, just because there was a question on the farm-made probiotics, I just want to give a quick formula for the natural farm-based probiotic. It's based on the Indian traditional medicine, like the Chinese traditional medicine. It's called Ayurveda, because it has been used successfully in many organic farms. So it's called Panchagavya, that means 5 ingredients in that, all natural, and 3 coming from the cow. Okay, India, you have a lot of cows. So the cow manure, the cow urine, and even the ghee from the cow. Clarified butter, more sophisticated word for that. And then you add the yogurt. Then the jaggery as a sugar, like it's a biofloc system they develop. So natural yogurt, so they keep it fermented for, say, 3 days or something. It become a thick liquid, and they apply it to the farm, kind of 150 kg per hectare. So this has been accepted, certification done already in the organic farms. So this kind of systems available, and farmers find it. It's from their traditional wisdom rather than, because the biofloc system has been used for a long time in Indian and Chinese farmers in the carp ponds. Just ferment the rice bran and the cake powder. So all these systems work, but I'm also happy to see that the probiotics really work, because at least they are harmless. Because, as you said, 50% of them has nothing in it. That's great. That's a great idea that we can. Thank you very much.
Thanks for that, and I think that was a really nice way of closing. Not all probiotics are bad, but most are useless. But your comment brings us back full circle in terms of local knowledge, and how it would be really, maybe somebody's done it already, but it'd be really interesting to understand why this particular recipe works, and it obviously does. There's nothing more frustrating being a scientist and not knowing the answer. And then the second thing is not getting funding to try and figure out the answer. So we'd like to thank everybody for a really interesting conversation, and that concludes this session.
Thank you so much. The Q&A session went into a really fruitful and thought-provoking discussion. Thank you so much for the moderators and for the participants. So with that, we come to the end of day 1 of AquaSustain 2024. And we'd like to inform you that we have a dinner party organized at around 7 p.m. We have special show, food and beverages arranged for all the participants. So I request all the participants to relax a bit until then and join the dinner party at 7 p.m. without fail. And yes, now. And you have the invitation card for the party in the front pouch of your conference kit. You can use that. So it'll take another 15 minutes. So I will request you to relax a bit. So thank you for, and thank you so much for making day one a successful start with your participation engagement. Please join for the dinner party, and thank you. And it's an honor, pleasure in being your host for today. Thank you so much.